This is Timmy. Welcome to Three Old Tech Dudes. Today at my kitchen table workbench, we're going to revisit the Commodore 64 power supply that we previously repaired in our How to Fix a Dead Commodore 64 power supply video. The power supply is working great, but there are a couple of things I want to check out to follow up to that video, including something a viewer pointed out. Here's our regulator that we looked at previously. Redid. It's still working. One viewer had noted that, and I didn't notice this, but apparently the tab on these regulators, and this shows how much of a hobbyist I am versus, I'm an experimenter. I'm still learning. Apparently that's attached to the voltage out, the regulated voltage out. The previous one was attached to regulated voltage in. He was concerned that there would be shorts that would cause me problems, with the plus 5 volt shorted against the anything, really, because this will probably be energized with plus 5 based on, the fact that the bolt and screw are running through there, right there, right there. So, looks like the transformer is coated in plastic tape, so that's helpful. Not sure that would be a problem, but it's worked so far. So we're going to get that on the meter and have a look here real quick. You look here, sure enough, this yellow wire is the ground for the regulator. So this is your 5 volt ground to the Commodore. So if I touch this to here, to the other wire, you should, if I can hold my hand steady enough, get 5 volts on your multimeter, which we do. But if I touch it to the outside of the heatsink shield, you get 5 right there. So, I don't think that has any ramifications. In fact, I'm probably going to leave it alone because when this is sealed up, this does a pretty good job of separating based on its guards, because your transformer sits here and there's not really, once the lid's on, it should stay here, and I'll try to make sure of that. The original regulator, as seen in the other video, had, it was the negative, and we'll show that here. It was the negative output of the regulator that was attached to this, and that didn't seem to cause problems, so that ought to work. Okay, we've got the power supply all pulled apart here. We've got our oscilloscope probes on the diodes, on the rectified side of the diodes. So this section here is going to be the positive voltage of direct current that's rectified, and here's the negative side going back to the transformer. I've unwired the supply line into the regulator board so we can do some testing with this guy. Now what this is an oscilloscope. Of course, a lot of you viewing channel already know that. This is one I got from Nathan. He got a big stash of these, and they're pretty decent. They're older, but I've been learning a lot about it and how to use it. I had never used one, so I'll talk a little bit about what I've learned so far. Got some probes for it off Amazon. Got a dual channel, and I did get 2 probes, so that's fun. We're just using channel A today. So, first off, I'm going to show you how to read the voltage here. First, we'll show it with a multimeter as a reference, so we know that we're, getting somewhere close to correct. Get in here, get close. Set this to 20 volts DC. And we'll set a baseline for our voltage. I've done this already, and I noticed something. Well, with the regulator board detached, we get about 8.2 volts after the rectification occurs. I reach down here and reconnect my regulator board with my alligator clips. That loads up and it seems to draw more, and we get a higher voltage here. I won't pretend I understand what's going on. I have a lot more to learn about power supplies, but I thought that was interesting. So before we start talking about the oscilloscope, we've got 1x and 10x probes. The manual for the oscilloscope and a lot of YouTube videos I've watched suggest using 10x, and then you just adjust accordingly. So if you want to look at 2 volts per division, and a division, since we're there, is each centimeter square on this oscilloscope. So, 0 is center, 1, 2, if you're talking direct current, negatives on the y-axis down. So if you're in 10x instead of 2 volts, you would use 0.2. So that makes pretty good sense. So we will set this. How will we set this? We can set it at 1 volt. That way we got the equivalent of 10 volts per centimeter here. Make sure we're good and centered on the line. Got the intensity a little for the video. There we go. Okay, we're already connected as we showed. We have the regulator board in line, so we're expecting the 12-ish volts on direct current here, right? Okay. So what I did there is the ground just grounds out, so we'll put it in direct current. Put it in direct current mode. Let's look real close here. In this setting of 1 volt per division at 10x on the probe, you show roughly 12 volts because you have 0, 10, and 2 more marks. It's kind of hard to tell you guys, can't remember this right, but it is about the second mark there. So we're showing about 12 volts. It's about what we want to see. Notice how it's a good straight line. The voltage is very steady. That shows us our regulator is working. Our ripple filter on the regulator board is working because let's go down here and disconnect the regulator board from the transformer. Okay. Now let's look at our oscilloscope. Okay, look here. Let's see if we can get that stop moving here. Oh. Touchy, touchy. Basically, you're getting rectified top half of the AC sine wave here. It's still direct current, but it's dropping to near 0 volts. Each ripple it has there. Let's see if we can straighten out. There we go. Change our time base so we can see that a little better. Right here you're still getting up to about 12 volts here, but it's dropping almost to 0 volts. Each AC 60 hertz ripple. So let's see if I can get this. We'll look to the oscilloscope. We'll hook that back up. That capacitor, that 47 microfarad capacitor, is recharging and discharging every cycle. Basically like a battery that's recharging and discharging at high speed. And it straightens that voltage right out. So that tells me these capacitors are good or good enough for this power supply and don't need replaced. Answers our question.
Thanks for hanging out with us here on 3 Old Tech Dudes. Please subscribe to us here on YouTube for more tech old and new, tinkering at the workbench, repairs, ham radio, electronics, computers, and more. Please like this video and share 3OTD with your friends to help us grow the channel. We tweet at 3 Old Tech Dudes 1 on Twitter, and you can keep up with us on Facebook. Just search for 3OTD and look for our logo. Thanks so much for watching.